On this episode, we ran into some problems. But we're going to give away another one of these. Hey everyone, welcome to episode 14 of DailyIoT. My name is Kevin, and this is the third time I have filmed this intro. Camera and lighting issues, not getting any better. I'm trying to make it so this stuff is watchable. Let's hop right into it. I don't have any news today. I would like to, first of all, apologize to Everton Horning, who I have not heard from. Everton, if you hop back in on this episode, I apologize. I've been trying to mention you in episodes, haven't gotten an email from you, and so I have to give this away to somebody else. And the way we're going to do that, I'm not going to draw another name at random right now because we have new subscribers and viewers coming in all the time. And so we're going to reset this episode only. If you would like a chance to have me send this to you, hit me up with a comment below. Just anything, just say, hey, how long you've been watching, or feedback on the show. I always love to hear that as well. So comments, this episode only, I will pick somebody at random and send them the kit. Okay, like I said, there is no news, and so you guys know what we've been working on, the scooter project. So let's head over to the latest update.
So we cracked open the motor controller and logic board of the scooter, pulled it apart to see what it was like on the inside. We were hoping that we'd get lucky and that the control board had separate sections for the motor controller portion and the logic controller portion. Turns out we're wrong. It's all one board. So we need to adjust and figure out where to go from that. It's not totally surprising that it was one board, by the way. A lot of these components will have just one circuit print. It manufactures, it scales much better at scale, but for us it makes our pulling apart a little bit harder. So we have a plan on how to deal with that, though.
That's exactly right. And so what we have is, this is a diagram of kind of that motor controller that Matt was just showing you there. The battery and the motor come into these pins up here. There's an encoder on the motor so we can actually get information about how fast it's spinning, which is really cool. That's going to come in handy later. It's got a heat sink on it, some capacitors. It's got a microcontroller that's the brains of the whole operation. And then there's a Molex connector here that goes back up to our controls that we talked about yesterday. Again, those are just general purpose input-output lines coming down into that control board. And so now the goal is to get rid of that, so that we can control it however we want. We're hoping there's some major speed gains in our future, by the way, with this project, so we're hoping to see that. So the first thing that we want to do, we know how, because we talked about it yesterday, we know how to talk to the GPIO pins up on the controls, and so we're going to ignore that just for now. As a test, we want to see if we can take the battery and the motor, so just basically this chunk over here, and see if we can get control of the motor through our own means. And what we're going to use for that is a Spark core, and we'll talk about the choice for that later, but right now that's just going to be the platform that we're going to do some testing on. And we have a motor controller actually that can drive huge motors up to like 100 amp loads. And so the goal for today is to see if we can use a microcontroller, specifically the Spark core, and a motor controller to see if we can get control of the motor as our next step. Okay, so we're on day 2 of the motor test. Lunch break is only so long, so we didn't get all the way to a functional test with the motor controller yesterday. But today we have hooked up a particle photon to a Talon SR motor controller and then to our electric motor, and using power from our battery. Now, we programmed a very simple program onto the particle photon, which is basically give the motor controller the right timings to stop the motor, go full throttle forward, back to full throttle reverse, and then back to stop again. And so I'm an idiot, and we weren't filming the first test of this, and so it actually worked. The wheels spun forward, got faster and faster and faster, came back, went full reverse, and then back to stop. However, after a few cycles of that, the wheels weren't turning at the slower speeds. They would only kick in when it was full forward. And so we turned the whole thing off. When something's not right, turn everything off. We pulled the battery out, yanked it out, and noticed that the motor controller was very hot and the motor was super hot. And so something's not right. It should not do that. And, this is a speed bump in the project road that we're going to have to figure out. I took apart the motor controller, and my best guess is that it's running off of an H-bridge to drive the motor. And I'm not an H-bridge expert. I'm not a motor controller expert. I know that this Talon SR basically just takes the voltage to full 24 volts in our case, down to negative 24 volts to drive it full reverse. H-bridge works differently. And so I need to figure that out some more. Matt and I are going to do a little bit of research, but definitely not driving the motor the correct way. And the motor controller that we were hoping to use that we had lying around does not seem like it's going to be a viable option. But this is the kind of stuff that happens. When you're doing a project, stuff's going to go wrong. You're never going to make it through without something happening like this. And that's just an opportunity to stop, regroup, get on the internets, hit Google up, and figure out what's going wrong so that we can keep moving forward. So that's the latest.
Okay, so after some more research, it turns out that the Talon SR motor controller that we were using is also just an H-bridge. I remember these from like a decade ago in college, but I had forgotten, went back on the internet, refreshed my memory a little bit, and it turns out that they are both H-bridges, which I'm not going to go into. That would make a good microcast talking about how an H-bridge works. But basically it's 4 switches, whether that's relays or transistors, that control voltage a certain way across motor pins to drive it forward and reverse. We're still not sure why that DC motor gets hot enough to fry an egg when we use the Talon controller. And so the one thing that we did notice is that there's a brake and a coast mode, which determines whether the H-bridge in the Talon drives an active brake within certain throttle ranges. We're going to switch that to coast on next week and see if that makes any difference. We got to get this figured out so that the motor doesn't heat up and melt on us. That's the latest update. One thing I did want to mention as far as like Internet of Things and learnings from this whole project is Matt and I have been working on this during our lunch break. And so we have about an hour each day to do this. And we'd all like more time on our projects, but I've found that having that constrained time window has really helped to focus our efforts and keep us moving forward. We don't have time to debate or to feel sorry about ourselves. We got to make decisions and keep moving forward, and it's been really helpful. Not as much as I would have thought. I thought it would have been really hard, and it's not easy. We've had to film this over a couple of days, but it's really an interesting exercise in constraining the time to kind of force a project forward. So just an interesting thought of the day for you there. And that's it. That's all we've got for today. I appreciate everybody watching. If you have not subscribed, I would really appreciate it. It would mean the world to me. I'll put the button up right around in here somewhere to click on that. And again, if you want a chance to win the SparkCore kit, just hit me up with a comment below. You can address it to me or Matt. It could be feedback, or it could be just to say, hey, would love to hear from people, especially new people that have been just joining and haven't said anything yet. Now's your chance. Get in and get a chance to win that kit. So I appreciate everybody watching. I hope everybody has an awesome day. Thanks for watching Daily IoT, the show where together we're learning all about the Internet of Things, one day at a time.